Welcome back to Real Clear Radio Hour, brought to you by the Competitive Enterprise Institute. I'm your host, Bill Frezza. Joining us for the second half of our show is Daniel Sarewitz, Professor of Science and Society at Arizona State University and co-director of the Consortium for Science, Policy, and Outcomes. Dan, welcome to the show.
Pleasure to be here, Bill. Thanks for having me.
Dan, I asked you on because your essay, Saving Science in the New Atlantis, totally lit me up. It was such a breath of fresh air in a debate that's become toxic, and you gave us all some hope. I'm speaking specifically about how big science has gotten itself trapped in what you called a destructive vortex and how technology can help pull it out. Start from the top. How did what President Eisenhower called the military-industrial complex CoOp science?
Well, it's a big, long story, but it really starts at the end of World War II when Vannevar Bush, who was President Roosevelt's basically his science advisor, and he was also the architect of the science enterprise that did help us win the war with the Manhattan Project and proximity fuses and things like that. When Bush was trying to figure out how to make a transition to peacetime after World War II in a way that would maintain the government's investments in science, which scientists, of course, liked a lot, but also free scientists from their obligation to military applications. So Bush wrote this brilliant political document called Science, the Endless Frontier, and it basically articulated what we all think of as the way science works, which is give a lot of money to scientists to pursue curiosity where they would like to pursue it. Good things will happen and we'll solve our problems. So Eisenhower really built on this rationale that said if we invest huge amounts in science and we allow science pretty much to go where scientists take it, we will build a reservoir of knowledge from which we can get the applications that solve the problems that face us.
How did the way technology grew out of the Industrial Revolution differ from this evolution of big science?
This is a great question, and we can even talk about how did what happened in the Cold War differ from that model, because the way we like to think about science and technology typically is it's what academics like me call the linear model, that scientists come up with breakthroughs about concepts in nature, and then technologists and others reach into their reservoir of knowledge and pick out things that they can use to then turn into technologies. Generally, things actually work the opposite way. The classic example is the rise of the field of thermodynamics, which is really, as basic as physics can be, very important fundamental understanding of really how the universe works. And yet, what stimulated the rise of that science was the desire to improve the performance of steam engines, of boilers, and locomotives in the early parts of the Industrial Revolution. We see very similar things going on during the early years of the Cold War. My favorite example is the discovery of the transistor effect at Bell Labs, which was really science as basic as it could be. It had to do with the behavior of electrons in semiconducting materials, and it launched a whole new field of scientific endeavor. But it was driven by the desire to improve the performance and to reduce the size and heat generated by electronic components that the Army needed to use to succeed in its endeavors.
So, Dan, when you look at the tremendous amount of funds that flow into big science, when did the American public get the idea that scientists were above human failings, never faced moral hazard, never knowingly published falsehoods, and should have their research funded by billions of taxpayer dollars with no connection to any tangible products or services?
Well, again, I think this derives from this idea of the linear model that was so beautifully articulated by Vannevar Bush. But I think there's a much deeper historical pedigree here, right? Which is, it almost in some sense goes back to Aristotle and to the notion that the pursuit of pure knowledge was really humanity's highest calling. And those who actually, just simply tinkered around in their workshops and made things were somehow doing lesser intellectual work. And I actually think that pedigree sticks with us. Although it's true that in the U.S., there has really long been a tension there. De Tocqueville, in his wonderful, Democracy in America, actually notes the kind of practical element of U.S. science. And it really wasn't until the late 1890s when we began to take seriously this idea that, in fact, we not only had to be good at making stuff, we also had to be good at generating ideas. There's nothing wrong with that, but it did take on this kind of cultural hegemony, really, especially as articulated by Vannevar Bush. And, the point I want to emphasize here is that it was a politically brilliant strategy because, first of all, it said that scientists doing their own thing, intellectually pure thing, would create all the knowledge that we needed to solve our problems. But it also meant that there would be no need for political accountability because, of course, only scientists have the expertise to judge the quality of their work. And so, therefore, anyone who tried to criticize that enterprise was simply acting against the interests of both science and society. And that's been a very, very powerful political, I think, and intellectual rationale for the scientific enterprise.
Dan, when you talk about the cultural hegemony of big science, almost all the academic scientists I know are totally unabashed about the demands for taxpayer support for whatever pet project they're working on. Where does this unshakable sense of entitlement come from?
Well, let me say first that I know some scientists who aren't like that. But I agree, there is a sense of entitlement. And I can tell you what first got me into this game, I'm trained as an academic scientist myself, was working on the Hill early in my career on the House Science Committee. And, I was stunned to see essentially the very same people who I had trained with also behaving as political actors. Part of it is that scientists believe this mythology of the purity of knowledge as well, right? So I think there's actually a strong quasi-religious belief that they're entitled to public investments precisely because they believe that society depends on what they do. And they're, of course, not entirely wrong about that. But the idea that brings with it no need for accountability or no need for linkages to actually the types of problems that society needs to have solved, I think is the source of deep pathologies that I write about in the article.
Examining what the public is actually getting for its money in this unaccountable funding regime, how has the replication crisis revealed a lot of rot at the foundation of big science?
Let me first just pull back for a second and talk about this notion of big science. Because there's two things going on here. One is, of course, there are major science projects, everything from colliders to the Human Genome Project that attract lots of money to do particular things. So that's one type of big science. But the other type of big science is simply the enterprise as a whole. And there are now tens of billions of dollars being spent on academic research, and whether or not that's a lot or a little can be debated, or whether it's enough can be debated. But I think the point is that the size of the enterprise is enormous compared to what anyone had in mind in the 1950s when his plan began to be implemented by the federal government. And so there was built into the system a kind of exponential growth of the size of the enterprise itself that meant inevitably that demand for federal funds would outstrip the ability of the government to meet that demand. And this was actually predicted as early as 1960 by a historian of science named Derek Price at Yale. So there's nothing surprising about this. The point about the replication crisis, and for listeners who aren't familiar with that, there's been, I think, increasing revelations, especially in biomedical science, where really about half of our government investment in science goes, that a lot of the science is actually not very good quality, and that efforts to reproduce it often fail. But this is part of, I think, a much bigger quality problem that comes with the evolving kind of culture of academic science, where basically quantity outstrips quality in terms of what the incentives are for professional advancement. The fact is that a couple of million articles a year are published out of the sciences. It's very difficult to know what the value of those are or what the quality of that body of knowledge might be. I think there's a broad, very disquieting awareness in the scientific community. And, many scientists involved in this are quite willing to acknowledge it, at least around the water cooler, that all the incentives are around volume, that scientists get promoted for the amount of money they bring in and for the number of publications that they're able to churn out and how well those are cited. And everyone's playing in that game. And I don't think scientists are particularly happy about it, but they don't know what to do because they're trapped within the system. So the replication crisis is just one manifestation of a system that's really become very inward-looking. It's really become about how do we replicate ourselves? How do we get more graduate students into the system to help us produce more research and more postdocs, even though there might not be jobs waiting for them afterwards? Along with the entitlement mentality is a growth mentality.
I can't tell you how disappointed my thesis advisor was 40 years ago when I bailed out to go into industry.
This is a really interesting point, too. It's replicating the culture is also part of what goes on. Of course, that's what goes on in any institution. I think my thesis advisor would probably relieved to get rid of me. But in any case, it's true that the science enterprise is very much devoted to the notion that it must always grow larger and it must always receive more funds without asking, what's society getting for this and how ought we to organize ourselves not to focus on always growing, but on ensuring that we provide the best value back to society.
Dan, let's move on to some of the political controversies fueled by big science. You write that scientific rationality is a terrible foundation for progressive politics, yet liberals seem more devoted to it than ever. What did you mean by that?
What I meant specifically by that was, I think, in the early 2000s, especially in the presidential elections that pitted Al Gore against George W. Bush and then John Kerry, science turned out to be a politically powerful tool for Democratic Party. I think the climate change debate, the fetal stem cell tissue debate, all were things that were pretty good at mobilizing certain parts of the Democratic constituency. And also it turned out that it was kind of a nice political thing to be able to accuse Republicans of being anti-science. It wasn't entirely an unjustifiable position, but most importantly, it was good politics. And, just as Republicans have often been able to talk about Democrats as soft on defense, for example, or not interested in business, I think that Democrats managed to make a fairly strong case that it was difficult for Republicans to fight against, that they were not devoted to science. And yet, when you look at actually the consequences of politicizing science in this manner, and I should say I think both parties are highly guilty of politicizing science. We can talk about that in a minute. What happens is you end up substituting debates about science for underlying debates about politics that really are the nub of the issue. And climate change is kind of the mother of all examples of this.
Well, let's talk about the environment. As a society, we've done a tremendous job cleaning up our air and water over the past 40 years, yet environmentalists seem to get angrier and angrier every year, demanding more power, more regulations, and more control over the economy. It looks like they found their dream issue in global warming, which has surely driven a giant wedge into the body politic. Why do you say that the well has been poisoned on this issue?
Well, let me first say I'm sympathetic with the notion that protecting the environment is very important. I think we did do some of the easier stuff in the early decades of environmental regulations, and often that was done without the full endorsement of industry or conservatives. So I think it's a difficult issue, but I think that the idea that science should drive politics has been used by Democrats and by people concerned about climate change in ways that are very, very damaging to the issue and to science and to democracy. And here's what I mean by that. I think the basic physics behind climate change is pretty well established. I think the idea that humans are contributing to anthropogenic climate change is a pretty defensible, it shouldn't be a particularly controversial point. The question about what to do, though, is extremely difficult. And the global economy is extraordinarily dependent not only for its functioning, but for serving those who still need to be part of a growing global economy. It's very deeply dependent on fossil fuels. And getting off of fossil fuels in the short term is simply not going to happen. And I think that the framing of fossil fuels as this evil thing that is some kind of fundamental human sin, as opposed to recognizing that we've got a difficult dilemma here. We need to figure out how we're really going to manage, and I do think we need to decarbonize the global energy economy. But in the meantime, we need to do it while we're also providing livelihoods for good livelihoods for people who don't have them, maintaining the ones for people who do, and recognizing that a vibrant economy is necessary for civil stability and political stability.
When it comes to solving this problem, why do you believe that technology unites while science divides?
I do believe that. And the reason is that climate change, and I should say there's lots of other issues this applies to. It applies to whether women should get their mammograms in their 40s. It applies to what levels we ought to restrict certain toxic chemicals in the environment to. It applies to what food we ought to eat. So there's lots of issues. Climate change is the most difficult because it's the biggest scale. The problem with these issues as science issues is they are very open. You can ask many different questions and come up with many types of different answers. If you want to, for example, predict what the role of solar energy ought to be in the future, you can use any set of assumptions you want to show any future that you want. And you can do the same with nuclear energy, and you can do the same with carbon capture and storage. And therefore, everyone gets to have the scientifically validated future that they would like. And what this means is that the science simply becomes a proxy for the political debates that are going on underneath the surface. And this is why I say it's bad for both science and politics, because science becomes politics by another name. On the other hand, I think technological innovation, look, I think it would be wonderful if we could wave a magic wand, have carbon-free energy, and suddenly solve the climate change problem. It's not going to happen. The paths are going to be technological. They're going to be driven by innovation. Innovation mostly takes place in the private sector. And I'll tell you, frankly, I find it baffling that a centrist or center-right Republican hasn't stepped forward to take over the climate change issue, because I think they could. I think in many ways what to me seems like the right path forward politically on climate change is something that should appeal to mainstream Republican values, which is we can imagine great paths of economic growth, tremendous opportunities for technological innovation, tremendous opportunities for new development of companies, and tremendous opportunities for economic competitiveness. All of these things could and should be a part of the global climate change agenda. It should be a technology-led innovation agenda on one side. We could talk about adaptation in a minute if you'd like. It ought to be a unifying agenda because these are where the solutions are going to come from. But we've gotten so sucked into, and again, both sides, I say a pox on both their houses, both sides have gotten so invested in this debate about what's happening, how serious is it, that we've missed the opportunity for a win-win.
Dan, on the point that scientists can forecast any future they want, I'm very familiar with computer modeling, having been involved in that in my career. It's being used to design everything from integrated circuits to airplane wings. What makes the long-range forecasts of climate computer modeling different from the examples I just cited?
Yeah, fantastic question. This is central to the premise of the whole article. The difference is that designing an airfoil, an airplane wing, or designing a gas turbine and using combustion models, you have a closed system where you can very quickly provide feedback to your model about what works and what doesn't. If the efficiency of your gas turbine doesn't increase, if the airplane doesn't take off and use less fuel, then you know your models are wrong if they told you they were going to do that. The coupled Earth-atmosphere, ice-biosphere system is just an incredibly complicated open system that we don't fully understand. Models are valuable ways to test assumptions in trying to understand aspects of that system, but the idea that we can predict the system as a whole with any accuracy for long periods of time, I think is a delusion. It doesn't mean that we can't know things about it. And again, it doesn't mean that the basic thermodynamic conclusion that pumping CO2 into the atmosphere can contribute to temperature increase isn't correct, or that we shouldn't worry about that. But it does mean that the idea that we can have very specific predictions about what's going to happen at local levels or regional levels, I think is a fool's errand. It ends up throwing the models into the realm of politics in a way, again, that's dangerous for science, dangerous for democracy. And the lesson here, I think, is that science is most valuable when we see tight feedbacks with technological innovation, because that is where the science is held accountable to particular applications most directly. And I think that's one of the lessons of the Cold War, and that's really kind of the big part of my argument, that if we don't, it doesn't have to be technology, it can be any application, but if we don't make the science that we're doing accountable to applications in the world that matter to people, then science can go off half-cocked and in any direction that it would like, and that's really what we're seeing with this replication and quality problem in science.
So Dan, taking us back to the big picture, you've recommended adaptation, innovation, wealth creation, and economic growth as a solution to many problems facing us. What does this say for the role of science in addressing complicated issues like climate change?
Well, I think science can, first of all, give us some sense of just the big boundaries of the problem. And it can tell us whether or not we really ought to be concerned about something or not. It cannot tell us what to do. And I think that for problems like climate change, once we've realized that addressing the problem is significantly political, we have to give up on demanding that the science solve the political aspect of the problems and instead think about how can it be used to help us advance solutions. And so this is, I think this is true with lots of different issues where we see politics and science mixed up with each other. And so, again, just to repeat a point I made a couple of minutes ago, it's where the science, even fundamental science, very basic science, where the science is closely linked to the solution of real problems, either through action by humans or through technological innovation, where we can test the validity of it quickly in ways that allow us to know which areas are worth investing in and which areas are not. I think this is the history of scientific advance. I think if you look at the incredible technological world that we have today that largely did come out of the military-industrial complex. We can see that amazing advances in science mostly occurred because they were following the path that was blazed by technology. This is not something that appeals, I think, to the self-image of many scientists, but I think historically the story is a pretty clear one. We want scientists to be free in the laboratory to do their work completely unencumbered by political controls, but the science enterprise as a whole, especially if it's receiving public funding, is one that needs to be accountable for the applications that we're expecting from it and the benefits that we demand from it.
Dan, it's been so refreshing digging into your work. Thanks for coming on the show, and let's do it again sometime.
It was really fun, Bill, and I look forward to it anytime.
That was Daniel Sarewitz, Director of the Consortium for Science, Policy, and Outcomes, here on Real Clear Radio Hour, brought to you by the Competitive Enterprise Institute. I'm your host, Bill Frezza. You can check out Real Clear Radio Hour on Facebook or follow us on Twitter at Real Clear Frezza. And while you're at it, take a look at realclearfuture.com for daily updates on the next big wave of technologies. We'd like to thank our sponsor, Old Boston Restorations, for their support. Old Boston is a boutique property management company in Boston's South End. Visit them online at oldbostonrestorations.com. That wraps up our show for this week. Please join us next week, same time, same station. See you then.